Thank you very much for your talks. Very inspiring, very interesting stuff. So my personal opinion about AR, so I think one very, very big thing that enabled AR was Professor Kato's AR toolkit. I think that was something really, really enabling, because there were thousands of applications created, and like he was showing the dancing girl, it was clearly done by hobbyists, right? And it wouldn't have been possible without Professor Kato. And I think after that, my personal opinion, the biggest next milestone was PTAM by George Klein. Another tool which was shared by a researcher to the community and which enabled a whole new class of applications. I mean, still PTAM isn't used as widely as AR Toolkit, but I think this is a topic for AR, that we need this kind of shared tool. So, or the sharing of tools between researchers and the community. So I would like to ask the panelists, so what can you see, like what are upcoming tools that can come from the research community to business and art? And what are things that business and art needs from the researchers?
Before ISMAR, we had a very interesting meeting at Trackmark workshop. I think building such ground truth tool together business and academy is very interesting. To share these data sets and to have a real ground truth data that you really can check whether everything is going right, where you can compare, where you can see what different algorithms perform at different sequences. And some of the sequences of Professor Kato, I think, were supposed to be in the Trackmark. And you could try your own algorithm and see whether it handles correctly the bicycle case, for example, or it can track this hard construction building inside the Japanese house. And I think business and academy could really collaborate with this kind of data and help each other in the evaluation. And I think this is a very good step towards such collaboration.
Well, I think that if we look at the problems at hand, there are basically three problems. There's tracking, there is generating content, and there is visualization. And yes, we do need to support the H&D research. I agree. Because I want to get rid of that mobile phone. I mean, okay, mobile phones are good to navigate in the city and whatnot, but there are other experiences that go beyond that little screen. And there is also, I was yesterday talking about cinema and the shift that we see there. I mean, there is a huge difference of going to a movie theater. Size does matter. I mean, the huge screen and the small screen, that's something completely different. And we tend to forget that. And, well, I mean, I think we should really look at these three topics and also understand what the challenges are. So the question for AR is in that sense quite difficult, but maybe we could think also of always, and I think somebody proposed this as well, thinking of all the problems at the same time and also at the same applications at the same time to get a business or a workable new tool.
Yes, you want. Okay, so I think not the HMD, but our field of view to look at the research issue is too narrow because we have to solve so many types of the issues to achieve the good AR in systems. Actually, in this ISMAR, the topics of research is not so many. So we have to collaborate with not only the artists and designers, but also the other types of the researchers and the engineers. It's important.
Maybe one thing about the HMDs, because I was working in Canon, and I saw that basically they could build that HMD that you want. They could do it, but they don't see the business case. right? Because there's no need currently, right? It's not like people come and we want that HMD. I mean, this community, we say it, but it's no argument for Canon, right? They need a really big business. But I think it's totally plausible that it's a huge business. But I think it's one way to get this HMD is to convince Canon. And maybe also, I don't know, Professor Roller, I think she could also build such an HMD. But I think also, like, what's the business case? I think
we're kind of over here discussing this. I'm from industry. I don't usually show up here, but I've been designing since the early 90s in both military and commercial. And I probably designed 15 systems myself. And we've come to the point, the last system we designed was about a 20 degree, 25 degree. And to your comment, if we're going to keep it in near the face right now, that you really have to get used to that. We've done 100 degree systems, they're out here. We can't get 100 degrees in close right now. There's no technology to support that. And even 40, there's kind of a need to move away from that. So we're kind of stalled out. We were developing systems pretty much, on a continuous basis for over 10 years. And about 2 years ago, the money just went away because the next increment has been prototype, 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 prototype. A good prototype right now today costs about $500,000. And when you get that done, to take that to make 10,000 units, which is what everybody wants at the minimum, is at least $10 million. And nobody's walking up to the $10 million. So the technology is kind of all lined up, but the guy with the $10 million isn't in the room. And without that, we're kind of, or without, some magic invention. I mean, we've seen some neat stuff happen. We've gone from CRTs to a whole series of displays, and OLEDs will be a huge breakthrough because they're self-illuminating. The illuminator goes away. The optics has gotten smaller and smaller, and the surface is more and more interesting. But there are some, for the guys doing the stuff on the head, there are some fundamental rules like the head is this wide. That kind of sets a rule base, and it's pretty hard to break the rules.
Kevin, we should mention to those of you who don't know who you are. Kevin Thompson is VP of...
Well, I was VP of Optical Engineering for a company called Optical Research Associates, and that company develops the software that most of the world uses to design optics, called Code 5 and Light Tools. As of Friday, we were acquired. I'm now a group research R&D director for a company called Synopsys, which is a silicon photonics company. But nonetheless, we'll probably be doing some of this.
I wonder if we could ask, I noticed that Professor Tamura is sitting in the front row, who directed, if I recall correctly, the mixed reality lab at Canon. Do I remember this correctly? Yeah. Where a lot of these things were designed, and I can't pass up the opportunity to have you comment on what you think is the future of this. And while you're thinking about it, let me mention to you, those of you who use the Wi-Fi from Face-Based Labs, how many of you have seen the Wi-Fi? It's a pretty small unit, very wide field of view, and it needs a lot of optical distortion correction, which was done in hardware, in logic. So I personally am encouraged that it's possible to build at least closed head-mount displays. Now, as Kevin mentioned, having it be optical see-through is a dramatically greater challenge with wide field of view. But maybe, if we think of the purposes in mind, it might be okay to have a video see-through system in which, we process the video image, doing corrections on that, as well as then corrections on the display itself. So it seems to me there are possibilities, if Dr. Kott's suggestion could be done, that we have new kinds of research problems that can be pursued. Professor, yes. Professor Tamura.
One moment. I have many things to say during this panel, but At this moment, I cannot fix my idea now. Probably give me 10 more minutes.
Fine, 10 more minutes.
I can buy a little bit of time for Murasama. One thing I'll comment is, I was saying in terms of business development, I think our field has been lucky to be able to leverage a lot of other developments for other things. For example, they didn't make all this graphics acceleration for the field of augmented reality. They did it because of games and other needs for real-time computer graphics. We're leveraging the fact that people want mobile phones, and all the engineering work and the billions of dollars of investments into packaging the sensors, the displays, the communication links, everything down into the modern smartphone that we're all taking advantage of. They didn't do it for us. Webcams and other types of examples of these technologies. So really the question of things like HMDs or others, are there other killer apps that can push that, besides laws of physics that Kevin Thompson is mentioning? And I guess so far it hasn't been so much.
We have somebody in the audience?
Professor Thomas.
Yes, in fact, for the benefit of the youngsters in the room, can people identify themselves and their institution, please?
Bruce Thomas, University of South Australia. One thing that surprises me, because I started working with laser projectors, is that there actually sell a lot of them, and it is augmented reality, but people don't call it that. So Boeing buys hundreds of them. I mean, they use it for laying down the composites and painting and putting down details. It's very, very simple, but it is augmented reality. We don't push the winds we have forward. Another example was that, and I know it's other places but Adelaide, there was an artist that made these projections onto buildings. They called them Northern Lights. And what ended up happening was when he first did it, he constructed them by hand. But they were basically SAR, by hand SAR. Now, I think what happens in the scientific community, we're always just trying to push the boundaries and do, but I don't see it sort of retrospectively looking at what worked. Also, the stuff that came out of TV Munich, there's now products for the medical industry. Now, they're early products, but I think there's a lot of lessons to be learned from doing simple, elegant systems that solve particular problems and not try to boil the ocean, as it were.
I want to ask the panelists, or maybe people in the audience, that although I bridle and present the idea of killer app because I think that's foolish, because we don't know necessarily, but I think there have been some examples of products and developments that are starting to pay for themselves. And so one of the things I'm wondering about is, for instance, the Lego digital box. My guess is that pays for itself.
Actually, the Lego are very happy with it, and as I said, they have numbers. Like they did really studies whether this improves the satisfaction of the user, and the result was definitely yes.
Probably increase the sales also.
Yeah, but I don't have any numbers about this, but I guess so. As soon as the user is satisfied, I mean, of course the sales are getting higher. And the only thing we are getting is that we see that they are making it wider and wider. They started with like the test stations, and now it's getting more and more generalized. And this attracts very much the users and the publics, and also the kids. They like it very much.
Are there other examples of developments that have the near-term potential of paying for themselves that people know about?
Other examples? Yes, probably not so end users products, but as I mentioned in my presentation, there is the industrial augmented reality. There is the group of the Volkswagen group is using our technology to. It's not really optical tracking. In this case, it's based on Faro arm or robotic arm that gives the position of the camera, and then the camera is used just for the display, and this is used for discrete